Hello friends, today we will see logic gates. In a digital electronics, we have three basic gates: OR gate, AND gate and NOT gate. Okay, so these are the logic gates, and first we will see OR gate. What exactly the OR gate is, it's having like, if all the inputs, whatever input you have to the OR gate, if the inputs are low, then it has low output. If any one of input is high, then it will give high output. So the basic symbol of OR gate is like this. Okay, here we have A and B as input, and we can say O or Y as an output. If the A or B both are low, then we have output which is low. If A is high or B is high or both are high, then we have 0. Now this is digital electronics, so we will only talk in zeros and ones, highs and lows, right? So this gates having truth tables. So the truth table of OR gate is having A as an input, B as input and O as an output. So for both low, output is low. For both any one is high, output is high, and for both high, output is high. So it is having 0 0 0 1 1 1 for 0 0 1 0 1 1 0 1 1. Okay, so this is the truth table of logical OR gate, which is very basic and important gate in digital electronics. So we can implement this OR gate on a breadboard. Okay, so we will first implement that, where if both the inputs are low, we will get output as a low. Before proceeding further to make the connections of OR gate, first we will check like which resistor we will use, because we are having number of resistors. जिसका intensity, like resistor will help to limit the current to the LED, right? So here what we will do is we will place different resistor over here, and we will give voltage to the LED through the resistor and check the intensity. Whichever will give the good intensity, we will go with that resistor. So this will help you to clear your some basics also, right? So here we are placing the number of resistor, and just go through the color code. And if you don't know how to check the value of color code, please go and check the video that I already posted on my channel. Okay, so here I place the different values of the resistor, and using the LEDs, I do have number of colors over here. So we will just place the LEDs, okay, positive towards the resistor side and negative towards the ground. Okay, and then we will short all the ground and check the intensity. Negative of the circuit and positive of VCC we will connect over here, so you can see the intensity. Okay, so here we have the bright intensity. Now we will switch to the value which is 1K. Okay, so 1K definitely will give the lower intensity, because resistor here is limiting more current, because value of resistor is high. Resistor and current are inversely proportional as per Ohm's law. Okay, so this is how the intensity is lower than the our lower than this, right? So here it is quite lower, you can see. Now we will move forward. Here we have the value which is very higher, and that's a 10K. So you can barely see the brightness of LED. It's like very low amount of current is flowing through it. Okay, are you able to see that? Yes, this is how it is looking. So by checking all this, we will go with the 1K. Okay, this is the circuit diagram for the OR gate. Here we used two NPN transistor, and we are giving 1K, we are giving voltage to the base through 1K, right? So this will push this transistor into saturation and it will turn on. Okay, so any one of it, if any one of it will turn on, will allow current to flow through this and will glow the LED. So this is the logic behind OR gate. So I'll do the connection for it. Okay, this is how we done with the connections as per the circuit diagram. You see that, like if I give Like, if we consider this as a and this is a B, then if I high the A, I'll give the I'm getting the output. If B is high, then also I'm getting the output. If both are low, then I'm not getting the output. And if both are high, this is how the OR gate works. Okay, now the next gate we will talk about is AND gate. AND gate is the next logical gate which is important in digital electronics. The AND gate is represented by the symbol like this. Here we have two inputs and one output. So what the truth table of AND gate is, if any one of the input is high, AND gate will not give you the output. AND gate will only give you output when both the inputs are high. So that's the difference. Like we are getting 0 if we have both low, one low, or any one of input is low. But when we have the both the inputs high, we will get the output. And that's only now we will see in a breadboard how it will work. So what will be the circuit diagram for the AND gate, and what's exactly the change between AND and OR, we will see that. This is the circuit diagram of AND gate. Here we can see it's a A input and it's a B input. This is the output, which will like LED will tell you exactly how what's the output is. If LED is on, it will be high. If LED is off, it is low. So here what's the change is change here is we connected the LED in a different way. Okay, so we are connecting the LED at the collector side of the circuit. So let's implement the same circuit. So this is how the connection is. Here we have connected the circuit like this, and now I'm giving the input. If I'm giving input to both the transistor, if both are high, I'm getting output as a high. But now if I'm giving the transistor 1 only, like I need to put that here only, and if I'm giving 1 high, so VCC is going through the one transistor, so A is high and B is low, so that time I'm not getting any output. But if I'm disconnecting the first transistor from the VCC, then also I'm not. Now here I disconnected the first input, so I'm getting only B is high, there is no output. And if again both are high, that time we will get the output. Okay, so you can implement this circuit at home. And so this is how the AND gate will work. Okay, so this is how the circuit is working. Now we will see the next gate, and which is more important, which is also called as inverter. And it is very simple circuit, because it if you are giving high, it will give you low. If you are giving low, it will give you high. So we will go to the NOT gate. This is the NOT gate, which is having one input and one output. And simple, if you give high, you will get low output. If you give low, it will give you high output. So a single input is here with the NOT gate, and single output of course we will get. So for 1 it is giving 0, for 0 it will give 1. This is the only operation of AND gate. Now we will see the breadboard representation of the same. So this is the circuit diagram of the NOT gate. Here we hardly using one transistor, and the basic principle behind this, if you give the 5 volt to the input, it will give you no output. And because simply it will work as a, like if you give the 5, it will start conducting and it will directly conduct the voltage from here. So 5 volt will come from here and will start to will go to the ground instead of going to the LED. And if the transistor is in an off state, it will follow this path and will go to the ground through LED. And that's only the basic principle behind this. And this is the simplest circuit. Here we have do the connection as per the circuit diagram. So you can do that in the same way. Okay, and if I give VCC to the transistor, it will not allow LED to turn on, because as transistor is conducting in this case, the current will flow through this 1K but will go to the ground by this path, because there is a very low resistor and will not go through this. And now what I'm doing here is I'm just removing this 1K. This is how it will. Now it is giving simple power to the LED, and this is nothing but the inverter circuit, we also call as, and it's a NOT gate. All other gates are nothing but the next version of these three basic gates. We will talk about that later, but hope you understand the digital logic gates, which are basic and or and not. Do like the video and comment if you want to know more about it. If you want to do some college projects, LEDs which having, so please do comment and we will go through that video only. Okay, and do subscribe to the channel and press bell icon to get notification of the latest video. Thank you.